Hi and welcome to this overview module. In this module we will discuss important concepts in architecture basics of an ONTAP cluster. This is a theoretical module divided into smaller sections in which we'll talk about the different concepts that you may run into in a real-life situation. First of all, we'll have a look at the possible cluster configurations. We will focus on the most common setups. So this list is not complete, but it will suffice to get you up and running in a common cluster environment. Then we'll have a quick look at networking, in which we'll discuss some of the devices that have to do with networking, as well as the different network types. In the last section, we'll look at physical storage, which is about disks and aggregates. We will touch upon logical storage, and we'll also look at storage virtual machines. We will see that storage virtual machines are of prime importance for many actions that take place in a cluster. And finally, we'll have a first look at data protocols that clients can use to store data and to retrieve data. Since this is a high-level overview, don't worry if you don't get it all in one go. In later modules, we will definitely discuss things in more detail. So let's first have a look at the possible configurations. An ONTAP cluster can be as small as a single node. This means that there is one controller, or as it's usually referred to, a single node. This node runs ONTAP and is connected to one or more disk shelves. As you'll agree, this is not a very highly available configuration, because if something bad happens to the node, you will lose access to your data. So your data is not available for a period of time. Configurations with a single node are usually applied if losing access to your cluster at unpredicted intervals is not an issue. You should think of using the cluster for backup purposes. Backups are of course very important, but they don't have to be available 24/7. If you do want to be highly available, you should use an HA pair. This means that two nodes are connected to each other and to all of the disks available within that HA pair. So one node can take over the disks of its partner and service the data until the failed partner node comes back up. This is also vital if you want to do an upgrade, or if you want to stop the partner node for other maintenance tasks, without losing access to your data. We'll talk about the orange and purple lines in a second. Instead of running a single HA pair, you can also add multiple HA pairs to the same cluster. This is referred to as scaling out. You can have as many as 24 nodes or 12 HA pairs in one single cluster. There are some restrictions based on the protocols you use, but the absolute maximum number of nodes is 24. Now, an important note, if you want to have more than one node in your cluster, you should always think of one or multiple HA pairs. It is either a single node or an even number of nodes, like 2, 4, 6, 8, etc. You cannot run a 3-node cluster, for example. The same goes for removing nodes from your cluster. You can only remove nodes in pairs. If you, for example, would remove node 3, you would also have to remove node 4. Now, the purple line represents the cluster interconnect. This network is used for many purposes. Most importantly, it's used for cluster configuration data. All nodes in the cluster will need a synchronized configuration of whatever goes on in the cluster. Also, the cluster interconnect is used for cluster heartbeat, to check the presence of all nodes, and also data can traverse from one node to the other node in the same cluster. This is all done via the cluster interconnect. This network is often referred to as the cluster's private network, and it's never accessed by clients directly. And of course, it is a redundant network. In this picture you only see one purple line. But in real life, there are at least 2 physical connections per node, and if you need more bandwidth, you can add more connections. The orange line between the two partners represents the HA interconnect. This connection is primarily used to mirror the data from one controller to the other before acknowledging to the client that the data is safe. This is called NVRAM mirroring, because every node has something which is called non-volatile RAM, or NVRAM, and that will temporarily store data until it is actually written to the drives. This NVRAM is battery backed, so the data in there will survive a reboot. We'll discuss this in more detail when we start talking about storing data later on. And the blue lines obviously represent the connections in one single HA pair to the disk shelves connected to the HA pair. So in short, a node in an HA pair is able to take over the disks of the partner node. As with the cluster interconnect, the single blue lines should be interpreted as redundant paths to the drives. So to summarize, a cluster needs a minimum of one single node, and that is not a highly available configuration. The absolute maximum number of nodes is 24, or in other words 12 HA pairs. All nodes in the cluster are interconnected via the cluster interconnect network, which is a redundant configuration. And the HA interconnect is used between two partner nodes in the same HA pair only to mirror NVRAM. And finally, both nodes in an HA pair are redundantly connected to the shared disk environment, and this is why a node can take over its partner disks when needed.